First thing you do, click the subscription button and enter a couple of subscription ID information bits. So you're going to give it a token name, a key, and you got to tell it your domain. This configuration polling interval number here, in most cases, we're going to leave this at 10. Now you might ask, like, well, what does the Netskope side look like? So when you log into Netskope, you will go into the settings submenu, and you'll see that there's a tools option, and below tools, you'll see REST API v2. It will give you, you'll see a page that looks a lot like this. You are going to hit new token, and you will add these two elements. You'll do a read only for the IPsec POP API endpoint, and you'll do a read write for the steering IPsec tunnels endpoint. The POP one is for giving them a lat long and getting back a list of available POPs. And the IPsec tunnels API is for configuring the tunnels themselves. Okay, so this works just like all the other what are called policies. So the first step is to insert the Netskope Cloud Square into your policy order, depending on how you want to set it up. You select in the tree the appliances that you want to be Netskopified. So select them in the tree, go to the Netskope tab, and then click Netskope Association, and then you either click Add or Remove. That's it. That's really all there is to it. If you click Add and you hit Save, then a bunch of stuff starts and happens on the back end. Let me take you through that real quick. So the orchestrator reaches out, or it collects a list of, it collects location information from the appliance. This is, I want to call this out here, very important. You must put a valid address, a physical address into the Edge Connect when you provision it. It's very important. You want it to automatically appear on the map. If it doesn't auto position itself on the topology map, then you probably entered an address that doesn't work or is invalid or whatever. So you want to make sure that you have a valid location configured for the Edge Connect appliance. The orchestrator will get that location. It will send that string-based location address information to Google. It'll get back a lat long. Then it passes that lat long to Netskope's POP API and says, hey, based on this lat long, what POPs do you suggest? Netskope then responds back with a list of the top 5 closest POPs. We take 2 of those POPs, the top 2 closest ones that are in the same country as the Edge Connect, and then provision the tunnels on the Edge Connect. And on top of that, create IPSLAs across those tunnels to the POP itself. So that's what it's doing. Every time you associate the appliance with Netskope or Zscaler for that matter, this process is what kicks off and runs. So once you associate the appliance, you hit apply, it runs through all of its process. This is what it will look like. So you'll get a listing of the appliance, the interface labels. It does show you the POP name in the discovered area. The connection status, when you see this says up, that means that's a very meaningful thing. It means the tunnels are all up and the IPSLAs across the tunnels are all up. If anything is down or malfunctioning, the connection status won't be up. So this connection status doesn't just mean, hey, we connected to Netskope and provisioned the tunnels. It means the tunnels that we provisioned are functioning and up and passing traffic. If you look closely at the pass-through tunnel names for any of the automatically created IPsec tunnels, we call them pass-through tunnels, you'll see that it has this format. It'll say third party _ the name of the third-party service that we're integrating with, the label, then it will say primary, secondary, or backup. So this is in reference to the label's state. So the label itself, INETC here, is a backup label. So that means it's going to say backup right here. The final value on the end, that is the Netskope POP. So we get back, we ask the API for a list of POPs, we get back 5 POPs, and we pick the top 2. The very top one is N1. The second closest POP to you, Miami in my case, is N2. So up here at the top, if you look at my mouse, ATL1, that is N1, and MIA1 would be N2. Let's talk a little bit about IPSLA. So this is something you have to explicitly turn on. You can see I'm kind of marching across. We talked about subscriptions. We talked about interface labels. We skipped tunnel settings because you're just not going to mess with that. Don't touch the tunnel settings. Leave them at their default value. There's no reason that I'm aware of to ever change the default IPsec tunnel settings for the orchestration. Maybe in the future there's some reason, but for now, just don't touch it, leave it alone. But the IPSLA button is kind of important because this is not turned on by default. So you will click this button, come in here, and just flip this thing here to on. There's not much more you can do. For the Netskope orchestration, you cannot specify an address of your own. When we do the POP API call, we get back a list of the top 5 POPs. For each one of those POPs, they have a dedicated 10.30. something IPSLA probable endpoint. It's a specific IP per POP that you're supposed to ping to verify if the tunnel is up or not. So source interface, loopback. Don't use LAN 0 or WAN 0. The keep alive interval is how often we ping. So literally one per second. For ping, that works really well. For HTTP or HTTPS, you don't want to set the keep alive interval to 1. I think by default it's set to 5. I usually set it to 2, but not 1. So this is how often we ping. The sampling interval is the rolling average of the latency and loss measurements we're taking. So if it's 60 measurements, you're rolling that 60 measurements up into an ongoing average value. That average value is checked, see down here at the bottom, every 30 seconds. The Edge Connect checks the status of the IPSLA rule every 30 seconds. And at that 30-second boundary, if the rule is down, then raise an alarm, take the tunnel out of service, and so on.